could also take it as m is to n. Perfectly fine, right? Eventually you have to find the ratio. So let us just take lambda is to 1. One advantage would be there is only one unknown, so you need only one equation. Alright? So lambda is to 1. Let us write the coordinates a comma b. B is minus a comma minus b. And p would be a square comma ab. Alright? So let P divide AB in the ratio lambda is to 1, right? So then by section formula, yes, A square would be equal to this ratio multiplied by this coordinate, right? Always remember in section formula, we will multiply opposite numbers in the ratio and the coordinate. So lambda into minus a, then plus 1 into a to a divided by lambda plus 1, right? So now you see there is only one unknown here, lambda, which means that one equation is enough, which means I don't actually have to write the next coordinate equation, correct? So cross multiply lambda a square plus a square equal to minus a lambda plus a. Bring all the lambda terms together. Why? Because we want to solve for lambda. We are trying to figure out the value of lambda. So bring this here, lambda into a square plus a would be a minus a square, right? Which means lambda would be a minus a square upon a square plus a. You can cancel one a everywhere. You are left with 1 minus a upon 1 plus a, right? 1 minus a upon 1 plus a, which is option 4. Got it? Okay. You can cancel one a everywhere. Now, often students get confused when they take a slightly different diagram. Alright, so consider this a note. If by chance I had taken a, b, p, and if by chance instead of lambda is to 1, someone let's say takes 1 is to lambda, we should still get the answer, correct? In this case here, we will get, if you follow the same rules and same procedure, you will get lambda as the reciprocal of correct answer. You will get lambda as 1 by a plus 1 minus, 1 plus a upon 1 minus a. But this is not the correct answer. Many times students will write this and they will consider this, and you see this option is also there. So then answer is, the correct answer, 1 is to lambda, that is 1 by lambda, and 1 by lambda is 1 minus a upon 1 plus a. So this is a very important point that some students struggle with, that when we are asking P divides AB, it always means that AB, so the ratio towards A would be first. So you are always looking for this length divided by this length, which means this ratio is, this number is to this number. Okay, so just be careful about that. So then this would become the answer. Alright, okay, let us proceed. A point of trisection of the line joining the points minus 1, 2, 3, minus 4, near to 3, minus 4 is what? Now you understand what is point of trisection? It means if I take the point A and B, right, minus 1, 2 and 3, minus 4, and then let us say there are 2 points P and Q such that P and Q will divide AB equally in 3 parts. Alright, so then we want point of trisection near 3, minus 4, right? So Q is the point of trisection near B, and now draw this again. This is A and B, Q. This is just for your convenience while writing the formula. Q, let us call it H comma K. A is minus 1 comma 2 and B is 3 comma minus 4, right? So Q divides AB in the ratio now. Can I call it, is the ratio 1 is to 2? You can say it is 1 is to 2, right? Because this is 1, this is 2. but don't, because when you say Q divides AB, which means the number towards AB should be first. So 2:1, and this is very important. You can't say Q divides AB in the ratio 1:2 is wrong. Q divides AB, this is AB in the ratio 2:1, right? Which means H, instead of Q, let us write Q, H comma K. H comma K, right? So then H would be, right, multiply, cross multiply the number and the ratio. So 2 into 3, 2 into 3 plus 1 into minus 1 upon 2 plus 1, which would be 6 minus 1, 5 by 3, 2, right? So H is 5 by 3, K is minus 2. So 5 by 3 comma minus 2 is your point, right? Which means Q 5 by 3 comma minus 2 is the point of trisection of AB near B. Got it? Okay, let us proceed then. P minus 1 comma 4, Q 11 comma minus 8 divides AB harmonically in the ratio 3:2, then A and B are. Okay, so you understand what is harmonic division, right? If you take points A and B and P and Q, right? So P and Q are harmonic conjugates implies P and Q divide AB internally and externally in the same ratio. Alright, that is why we are calling them harmonic conjugates, that this ratio AB is to PB will be the same ratio AQ is to BQ. Alright, then there is a property of harmonic conjugates. Okay, what is that property? That if PQ divide AB in M is to N ratio, then automatically, now there is a long geometric proof for it. So in fact, if you want, you can try and prove it on your own. But if PQ divide AB in the ratio, let me just make it clearer. In the ratio M is to N, then A, B are also harmonic conjugates that divide PQ in the ratio M minus N upon M plus N. Okay. Now why are we using this property? Because you see P and Q are known, but A and B are not known. You know, the original points are not known. So if you want to figure out A and B, you will have to write x1, y1, x2, y2, 4 unknowns. You will need 4 equations. It will take a long time to solve. So instead of, you can definitely try and do that. But instead of doing that, we will just use this property and we will say AB are points, A and B are points that divide PQ in the ratio M minus 1 upon M plus 1. Again, internally and externally, right? So first here, what is M minus N, M plus M? So here, M is to N is given as 3:2, right? This is the original ratio of division, which means m minus n upon m plus n would be 3 minus 2 by 3 plus 2, 1 by 5, right? So what it means is, if you're taking P and Q, take this ratio as 1:5, and then you take point B, B should be on another side. You take point B, then 1:5. Okay, this is 1 and this is 5. Obviously this is not representative, this should be very small, this should be very big, but you understand. Okay, and anyway we are here just to apply the formulae. So write coordinates of P minus 1 comma 4 and Q is 11 comma minus 8, right? Call A as H1 comma K1, B as H2 comma K2, right? Now what will be H1? H1 is equal to, again apply your own section formula, right? 1 into 11 plus 5 into minus 1 divided by 1 plus 5. So 1 into 11 plus 5 into minus 1 divided by 1 plus 5, correct? How much does that come to? 11 minus 5 is 6 upon 6 is 1. K1 would be 1 into minus 8 plus 5 into 4. 1 into minus 8 plus 5 into 4 divided by 1 plus 5 again, which is 20 minus 8, so 12 by 6 is 2, right? So A is at least the point 1 comma 2. Is 1 comma 2 there? 1 comma 2 is there in only one option, that option must be correct. But let us verify, let us check B also. Now this time B divides PQ externally in the ratio 1:5, right? Once again P is minus 1, 4, Q is 11 comma minus 8, alright? So B is H2 comma K2, right? So H2 would be, a lot of students again they get confused with external division, okay, because they don't know which ratio to multiply with which coordinate. Just remember, if BP is 1, then you use 1 to multiply with Q. Think of it that way, right? So 1 into 11 plus 5 into minus 1, not plus, this is external division, therefore you lose minus 1 into 11 minus 5 into minus 1 upon 1 minus 5, okay? Once again, should I use 1 minus 5 or 5 minus 1? Whichever one you use first, you use that number first, right? So 1 into 11 and therefore 1 minus 5. How much would that be? 11 plus 16 upon minus 4. So this is minus 4, right? And K2 would be 1 into y coordinate of Q. So minus 8. 1 into minus 8 minus 5 into 4. So upon 1 minus 5, right? So minus 28 minus 20 upon minus 4, right? So that is minus 28 upon minus 4, which is 7, right? Which means B is minus 4 comma 7. Correct? Yes? Okay. So we have both B and A, therefore option 2 is correct. In fact, when we got that 2 itself, we said, okay, this must be correct. Alright, now there is a quick note here that in the beginning, you see, there will be a slight difference in the diagrams I have made. Here this goes BPAQ, but here it goes APBQ, right? Which means, if you follow this diagram, P is dividing AB internally, Q externally. Here also P is dividing AB internally, Q externally. but you never know which one you should take, 3:2 or 1:2, right? Okay, P divides AB. So here this part will be through, this part will be 2, this part will be 3:2. Okay, so just be a little bit careful. Sometimes it can happen that you might end up getting confused between which point is dividing internally and which point is dividing externally. Okay, in this particular case both the diagrams are matching, that P is dividing internally, Q is dividing externally, but it is always possible that there may be a mismatch. Okay, you might end up getting that P divides externally, Q divides internally, and some sort of, it can get messed up. So in such cases, just be careful about the diagram. In this particular question, that doesn't matter because they have not mentioned whether which point is dividing internally and externally. If it is clear, then you just use those cases. Okay, so we will just mention here point of internal division and external division are not explicitly mentioned. Okay, if they are explicitly mentioned, then you proceed according to that information only. Okay, all right. The coordinates of the point that is 2/3 away from -4,3 to 5,7. Okay, so there are points A and B 2/3 away. Let's take A as -4,3, B as 5,7, right? What does it mean 2/3 away from A to B? It means if I break A and B into 3 parts, then 2/3 away P. Alright, so we'll say let Q and P divide AB into 3 parts, 3 equal parts. Then P is 2/3 away. Two-thirds away from A to B. Alright, so this is basically the way it's written in English. You should be able to convert from that English into maths. Okay, so P is 2/3 away from A to B. Right. So in this case, P divides AB in the ratio 2:1. Right. Let us take point P as H, K. Now it is directly an application of section formula, right? Bisection formula. Now in case there is anyone who is not entirely sure how are we doing this cross multiplication. Okay, so I will just write the formula again. I should have written it in the beginning itself, but not a problem. Let me write the formula here. Bisection formula, H is equal to mx2 plus nx1 upon m plus n, right? Which is in this case 2 becomes m, 1 becomes n, right? And this is x1 y1, x2 y2, right? So nx2 plus nx1, which means 2 into 5 plus 1 into -4 upon 2 plus 1, correct? 2 into 5 plus 1 into -4 upon 2 plus 1, which means 10 minus 4, 6 upon 3, 2. Alright? Okay, 2 of the options have to, for H, once again draw this, A, B, P, 2:1, which this is M, this is N, no, it looks like they're multiplying, so let's be clear. This is M, this is N, A is minus 4 comma 3, which is x1 comma y1. B is 5 comma 7, x2 comma y2. Now this is h comma k. So this time we will write k. K would be, what is the formula? M y2 plus n y1 upon m plus n, which is m y2. So 2 into 7 plus 1 into 3 upon 2 plus 1, right? So that is 14 plus 3, 17 by 3. So h is 2, k is 17 by 3, therefore 2 comma 17 by 3, right? Which means p h comma k is 2 comma 17 by 3. Got it? Yeah? Shall we proceed? Alright, then let us do that. Okay, the perpendicular from origin on the line joining the points P, A cos alpha, A sin alpha, Q, A cos beta, A sin beta divides PQ in the ratio. Alright, so we have origin and there is a point P, there is a point Q. P is A cos alpha comma A sin alpha, and there is a point Q, A cos beta comma A sin beta, right? And so we are joining PQ and there is a perpendicular from O to PQ and we are being asked what is this ratio. So if you call this foot of perpendicular n, then we have to find this ratio m is to n, right? So let n be perpendicular from O to PQ, right? And we have to find what do we need to find? Qn by nb. Okay? Now, as you proceed, as you study this chapter and other chapters in this unit, you will later learn that there is a very clear formula for n. Okay, trying to find the foot of perpendicular, there is a very clear cut formula and you can proceed it. But right now you don't know the formula. Okay, so we'll have to figure out a way of doing it without the formula itself. Now, in such cases, observation is usually very helpful. Okay, so observe the coordinates of P and Q. Anything special about them? Both P and Q, both x and y coordinates have A in them, which means if something is there everywhere, you can for the time being ignore it. Alright, then cos alpha, sin alpha, cos beta, sin beta. What is special about them? Cos square alpha plus cos square alpha plus sin square alpha must be 1. Cos square beta plus sin square beta will also be 1. Now, how can I square add them? What must be happening? If I want to just square and add them, it means I am trying its distance from origin. Okay, so all of this will run your mind and then we will say observe that OP is under root distance from origin. So simply A cos alpha minus 0 the whole square plus A sin alpha minus 0 the whole square, which is under root A square cos square alpha and A square sin square alpha. So A square into cos square alpha plus sin square alpha, and that is 1, and this is just square root of A square, which is A, right? Assuming of course that A is positive. Okay, if you want, we'll just take mod A. Why make that assumption? Let us not make that assumption. So which is mod A? Now, whether it is positive or negative doesn't matter. So OP is mod A, right? What about OQ? And OQ would be under root A cos beta minus 0 the whole square plus A sin beta minus 0 the whole square, and follow the same steps. This will also be under root A square, which is also mod A. Okay? By the way, quick detour. Learn this because up to 10-7 many times you are told to write under root a square is always a. Not always. Okay? Under root a square must always give you a positive answer, which is why we put mod. Alright? Think about it like this. Square root of 2 square is 2. What about square root of minus 2 the whole square? Square root of minus 2 the whole square will be square root of 4, which is also 2. Square root of minus 2 the whole square is not minus 2. Okay, that's a separate discussion. Hopefully we can have it some other time. But square root of a square is mod a. Alright? So clearly OP is equal to mod a, which is also equal to OQ. Which means if you join these two, which means if this is O, this is P and Q, this is an isosceles triangle, right? These two sides are equal. Now what happens in an isosceles triangle? If I drop the perpendicular from O to the other side, by congruence, by symmetry, let us call this is point N. By symmetry, Pn equal to Qn, right? Which means triangle OPQ is isosceles, right? And ON perpendicular to PQ, which means Pn equal to Qn, right? So all we have done is we have first made this observation that OP equal to OQ, therefore it's an isosceles triangle, therefore the perpendicular will, the foot of the perpendicular will also be the midpoint, right? Which means Pn is to Qn is how much? 1:1. You see, you don't even need section formula. This is how you switch from coordinate geometry to geometry and back. Okay, sometimes you will use analytical equations, sometimes you will use pure geometry. Got it? Okay, then let us proceed. Q, R and S are the points on the line joining points P and T such that PQ equal to QR equal to RS equal to ST. Then this given point is the midpoint of what? Alright, very interesting. Q, R and S are the points on the line joining P and T. So let this be P and T. Okay, and PQ equal to QR equal to RS equal to ST, which means basically 4 separate segments, 4 equal segments, right? Q, R, S, right? Okay. Then PQ equal to QR equal to RS equal to ST. Now, also let M be the given point, which is 5A plus 3B upon 8 5A plus 3B upon 8, comma 5x plus 3y upon 8. Now, is there anything special about the way M is written? Is there anything special? Observe, 5 plus 3, 5 plus 3, 5 plus 3, 5 plus 3. Which means M is in a pre-made section formula form. Correct? So we will write M as first 5A plus 3B upon 5 plus 3 and 5x plus 3y upon 5 plus 3, right? Which exactly matches M x2 plus n x1 upon m plus n, comma m y2 plus n y1 upon m plus n, right? Exactly matching, which means P divides, not P, M divides P A comma X Q B comma Y in the ratio, and be careful about that. we need to know whether it is 5:3 or 3:5. Like I said earlier, it matters a lot whether you write 5:3 or 3:5. How do you decide that? You ask what is M and what is X2. Okay, clearly X2 is B, right? But we want A here. So 5A, if A is multiplying with 5, that means 3:5, right? If you want, let us just quickly draw the diagram. P, T and M, and what did we say? It is dividing in such a way that 5 is multiplying with A, right? So A comma X and B comma Y. 5 is multiplying with X, which means 5 must be here on this side. So 5 and 3. Can you see that? Be very careful about this. Don't write 5:3 just because we are used to writing 5:3. Alright. So now this is one diagram that we have, and this is another diagram that we have. P, T, in which exactly in the midpoint of PT is which point? PQ, QR, RS and ST. Right? So now simply by matching the diagrams, where is N lying? Think of this as M is 3/8 of PT, right? So it means if I break this into 8 equal parts and break this also in 8 equal parts, because then they will both have 8 equal parts, then where is M lying? M will be directly above the third part, right? Can you see that? Therefore, this is where M is lying, and directly by looking at the diagram we can be sure that by diagram M is midpoint of, they're asking M is midpoint of which segment? So M is midpoint of QR, right? Got it? Yeah, of course, you can also try and figure out, take this as some ratio λ:1 or m:n, and then match it with the given point and then figure out what is lambda and n. You can always do that. Eventually you will come to 3,5 only, and then you will have to figure out that then individually you take points Q and R, take all the options, PQ, midpoint of PQ, find its midpoint, midpoint of QR, midpoint of RS, midpoint of ST. You will have to find 4 different midpoints and see which one is matching with this. That is another way to do it, but I just think it's too long. This will be much faster. Got it? Okay. Let us proceed then. Okay. A comma B, B00 are 2 fixed points. If M1 is the midpoint of AB, M2 is the midpoint of AM1, M3 is the midpoint of AM2, etc., then M5 is what? Okay. Clearly a pattern based question. AB, A comma B, 0 comma 0, right? M1 is midpoint. So midpoint of AB, which means M1 will simply be A plus 0 upon 0 and B plus 0 upon, sorry, not 0, 2. A plus 0 upon 2, B plus 0 upon 2, right? Which is A by 2 comma B by 2, right? And then A, M1, M2 is midpoint of AM1, right? So this is A comma B, this is A by 2 comma B by 2, right? Which means M2 would be what? Sum divided by 2, right? So A plus A by 2 by 2 comma B plus B by 2 by 2. How much is that? 3A by 2 upon 2 is 3A by 4 and 3B by 2 by 2, so 3B by 4. So we have M2 also. Next M3, right? M3 is the midpoint of, we're just trying to figure out a pattern, alright? A, M2 we have figured out, M3 is its midpoint. So A comma B, and what is M2? M2 was 3A by 4, 3B by 4. So 3A by 4, 3B by 4. So M3 is midpoint, AM2, which means M3, what will be its coordinates? A plus 3A by 4 the whole divided by 2, comma B plus 3B by 4 the whole divided by 2, right? Cross multiply, it becomes 7A by 8. So this is 7A by 8, comma 7B by 8. Correct? So, no, that's not the final answer. That is M3. Are you beginning to see the pattern? Let us write down all the points once again. Right? This means M1 was A by 2, comma B by 2. M2, 3A by 4, comma 3B by 4. M3, 7A by 8, 7B by 8. Can you see the pattern? The denominator is just doubling, correct? And numerator is simply 1 less than the denominator, right? Which means, so by induction, Mn, let us not use the word induction, because induction is a very clearly defined procedure. We have not done the procedure. We will just say by generalization, Mn would give me what? In the denominator I will have 2 raised to n. Can you see that? In the denominator 2 raised to 1, 2 raised to 2, 2 raised to 3. So 2 raised to n. And here 1 less than that times a, comma same number times b, right? Which means what will be M5? M5 would be 2 raised to 5 divided by, in fact, you already know what is 2 raised to 5. 2 raised to 5 is 32 and 1 less than 32, so 31 a, comma 31 b by 32. Correct? Often in, okay, this is a point, so it is important to put it in brackets. Alright, often GI would expect you to figure out the pattern. Okay, in fact almost all of maths questions are all about pattern finding somewhere. Okay, so learn to do this quickly, right? And yeah, then let us proceed. If x1, x2, x3 as well as y1, y2, y3 are in GP with the same common ratio, then the points x1, y1, x2, y2, x3, y3 lie on a straight line, lie on an ellipse, lie on a circle, or are the vertices of a triangle. Alright, so first of all these points are in GP with the same common ratio. So let us take the common ratio as R. So we will say let A x1 comma y1 be the point A comma B, okay, for our convenience, and let common ratio be R, which means B x2 comma y2 would be what? Common ratio is R, no? So AR comma BR, just multiply by R, and C x3 comma y3 is AR square comma BR square, right? Now we need to figure out what is special about these points. Looking at all the options, instinctively, intuitively, what does it feel? That A is just multiplying with some constant, and we are getting the next coordinates, multiplying by the same coordinates, same constant, we are getting coordinates of C, right? Which means it almost feels like if there is A here, you just multiply a little bit, it goes to B, multiply a little more, it goes to C. Which means it looks like the same thing is being extended a little bit, right? Very, very vaguely, roughly speaking. So intuitively, we will always first check whether it's a straight line or not. Here it is the first option, but even if it's not the first option, we will check for straight line, right? So how do you check whether 3 points lie on a straight line or not? You take A, B and C, right? And we start with, check distance AB, right? Because they lie on a straight line if AB plus BC is AC. That is the idea. So check AB is equal to under root AR minus A the whole square plus BR minus B the whole square, right? Just applying distance formula. So you see, this is under root A into R minus 1 the whole square plus B into R minus 1 the whole square. Actually A square into R minus 1 the whole square and B square into R minus 1 the whole square, right? So you take that R minus 1 the whole square outside, you will just have R minus 1 divided by A square plus B square. Alright? Okay. So then leave it at that. Then that was AB. BC. Here of course we are assuming R greater than 1. But even if R was less than greater than or equal to 1, even if R was less than 1, if you do this procedure it will still work. Okay, you will just have to write the numbers differently. 1 minus R you will have to write, but you can work with it. Okay, so BC would then be under root, BC is under root, check coordinates, AR square minus AR the whole square. So AR square minus AR the whole square plus BR square minus BR the whole square. So you bring R square minus R the whole square outside. You see R square minus R the whole square will be here and here also. You will get A square and then B square. Bring it outside. So R square minus R under root A square plus B square, right? Hold on to it. That is AB. This is BC. And what is AC? Under root AC between these two. So AR square minus A. AR square minus A the whole square plus BR square minus B the whole square. Once again you will see R square minus 1, R square minus 1 will come outside completely. R square minus 1 under root A square plus B square. Okay, now observe all the expressions. This is R minus 1 into root A square plus B square. R square minus R into root A square plus B square. If I add these two, what happens? Root A square plus B square will be common. Take it out. R minus 1 plus R square minus R. R will get cancelled. You will get R square minus 1 into this number. So R square minus 1 into this number. Correct? So clearly AB plus BC equal to AC. AB plus BC equal to AC, which means ABC are in a line, also called as collinear. ABC are collinear, are in a line, lie on a straight line. Lie on a line. Okay? Alright. Now, the same question you could have attempted slightly differently. Alright. So, anyway, just to be clear, your problem is solved here. Okay? We know it is on a straight line. But, because this is just the beginning, I think it is good to know other ways of solving the same problem. Okay? So, if you had taken A, B and C, where your point B, instead of B, you take a point D. Let B be somewhere out here, you take a point D, where A will be obviously A comma B, and this is AR square comma BR square. take B as given, right? AR comma BR. For point D, no, we will take AR comma K. Alright, so let D AR comma K be collinear, not just collinear, in fact, so we are taking a point D with the same x coordinate as B, but y coordinate is different. K, some K, we don't know what is the value of K. And let this ratio be lambda is to 1. Okay, so let D AR comma K divide AC in the ratio lambda is to 1. Now you see, we have two unknowns. We have lambda as an unknown, we have K as an unknown. To figure out the value of lambda and K, we need two equations. But section formula gives us two equations. One equation would be in terms of x coordinate, one equation would be in terms of y coordinate. Which means using the two equations we can figure out the value of lambda and K. So let D divide AC in the ratio lambda is to 1. Use section formula to get lambda equal to 1 by R. Lambda becomes 1 by R, and then using that if you use lambda as 1 by R, then you figure out the coordinate of K, you will get K is equal to BR. Okay, this is something that you will have to do. It takes time, but you know section formula and you have done it so many times. So if in the exam you are able to think about section formula, then this is how you will have to proceed. You figure out first lambda, you will get lambda equal to 1 by R. Substitute, you will get K is equal to BR, and if K is BR, then automatically point B and D are coincident, right? Which means D is equal to B equal to AR comma BR, and ABC are on a line. Okay, so this is a twisted way of proving that they lie on a line. Okay. Twisted way. What are we saying? We are saying if there is a point D that has the same x coordinate as B, then if D divides them in some ratio, compulsorily y coordinate also must be that of B. Okay, therefore ABC are in a line. But it's a bit long, not advisable. In case you think about it in the exam, you can do this. Okay. There is actually one more way that you can use to solve this. Alright. Now this other way doesn't occur to the students a lot, but if it does, it is the fastest way. Okay, we will say let, or other x1 y1 is a comma b, x2 y2 is ar comma br. x3 y3 is AR square comma BR square. So now it is already given to us that all these points they have the same common ratio, which means y1 upon x1 will give you what, or x1 upon y1. x1 upon y1 gives you what, a by b. x2 upon y2, what is the ratio? R gets cancelled, you will again get a by b. x3 y3, R square will get cancelled, again a by b. So this is purely by observation. Observe x1 by y1 equal to a by b, which is also x2 by y2 and x3 by y3, purely by observation. Because then we can say the 3 points satisfy. Can we generalize these 3 independent equations? Can we generalize them? Yes. X upon y equal to a by b. These 3 points satisfy x upon y equal to a by b, where instead of x you use x1, y1, x1, x2, x3, instead of y you use y1, y2, y3. Which means, that is, cross multiply them, bx minus ay equal to 0. Which means all the 3 points satisfy this equation. But what is that equation of? It is a linear equation in 2 variables, which means geometrically it represents a straight line. That is enough for you. Which is which represents a straight line. A straight line. This is enough for you because this means the 3 points lie on a straight line. Correct? Yes. Now since we are looking at different ways of solving the same problem, there is one more way. Okay? And again I am telling you this so that you should be able to use different concepts to solve the same problem. I mean, not here, not every time, but you never know in the exam which method will occur to you. Okay, so here we are going to use vectors. And I know we have not done vectors in maths, but you have done vectors in physics. Alright, so I'm just borrowing that concept. We know that in vectors, any point x1, y1, not x1, y1, let's just take any point x, y can be written as xi cap plus yj cap, right? It represents a point on the 2D plane. So, x1, y1 can be written as, we know it is a comma b, which means I can write it as ai cap plus b j cap, correct? That vector. Then x2, y2, similarly, x2, y2 will be what? A r I cap plus b r j cap, and x3 y3 would be a r square I cap plus b r square j cap. If you look at the diagram, what it will mean is xi cap y cap always joins the points O to x comma y, right? Which means, wait, just draw it a little smaller. If you join a point x comma y to O, then OP then becomes xi cap plus y j cap, right? Here, no, let us write the observation first. What's happening here? You see, if I take r outside, I will again get ai cap plus bj cap. If I take r square outside, again we will get ai cap plus bj cap, right? Which means this is the point A, B and C. Here OC, which is r square into ai cap plus bj cap. So OC can be written as ROB, right? Because here if I just take R outside, it becomes AR I cap BR J cap, which is exactly vector OB, which is R square vector OA, right? And if you studied in vectors, when you multiply a scalar, which means when you multiply a number to a vector, it just gets extended. Its magnitude will change, but direction does not change. This you must have seen in vectors, right? Which means OC, OB, OA all have same directions. Correct? And if OC, OB and OA all have same direction, what does that mean? It means OC is R square, OB is R, OA is whatever the original length was. Okay? Which means OA, B, C are collinear. Not only ABC, even OABC are collinear. They will all fall in a straight line. Okay? So, by the time you're done with these 2 years, you should be able to freely and independently use whichever method occurs to you fastest. You will realize that the last 2 methods I showed you, the one based on y by x or x by y and the one based on vectors, this whole thing can be done mentally. You will not have to put pen to paper, which is why you should know these methods exist. Alright? Okay, then let us proceed. A1, A2, A3 up to AN are endpoints whose coordinates are x1, y1, x2, y2, x3, y3 and so on up to xn, yn. A1, A2 is bisected at G1. G1, A3 is divided in the ratio 1:2 at G2. G2A4 is divided in the ratio 1:3 at G3, and so on until all the points are exhausted. Then the coordinates of the final point obtained is what? Okay, so a lot of stuff is happening, but you are going to start with A1 and A2, and A1 A2 is bisected at some point G1, right? So we find its midpoint, which is G1. Then G1 A3. A3 coordinates are known, G1 coordinates are known. G1 A3 is divided in the ratio 1:2 at G2, which means by section formula I can figure out G2. Then G2 is known, A4 is also known. So G2 A4 is divided in the ratio 1:3. Once again use section formula at G3. So repeatedly if you use section formula, you will keep getting coordinates of G1, G2, G3 and so on. Then you just need to generalize it, because they are asking until all the points are exhausted, which means when you reach the nth point, what happens? You just need to generalize it into an n based form. Okay, so let us get into the battlefield. Okay, so a bunch of points A1, A2, A3 etc. are given. Start with A1 and A2. You already know whatever is given, so again I don't have to write everything once again. Start with A1 and A2. G1, right? G1 bisects A1, A2, right? G1 is midpoint of A1, A2, right? What are the coordinates of A1? x1, y1 and x2, y2. So its midpoint G1 would be what? x1 plus x2 by 2, y1 plus y2 by 2. We know this is G1 now. Then G1 A3 is divided in the ratio 1:2 by G2. So let us call this as G1 A3, and it is divided G2 1:2. So G2 1:2, where coordinates of G1 are known, the coordinates are known, and A3 is x3 y3. So G2, let us call it H2 comma K2, right? What will be H2? H2 would be 1x3 plus 2, let us call it H1 comma K1, right? Let us call this as H1 comma K1, and H1 comma K1 are given by this expression. So H2 would be 1 into x3 plus 2 into H1 upon 1 plus 2. Correct? Just applying section formula. So section formula. Then substitute this. H2 would be 1 into x3. We have to leave it like that, no, because we don't know what is x3, so we'll just leave it like that. 2h1. What is h1? h1 is x1 plus x2 upon 2. So plus 2 into x1 plus x2 upon 2, the whole divided by 1 plus 2. Something interesting happens now. This 2 will get cancelled. What is left? x3 plus x1 plus x2, which is x1 plus x2 plus x3 by 3, right? Similarly, if you check, K2 will also turn out to be y1 plus y2 plus y3 by 3. Are you able to see the pattern now? Because your H1 was x1 plus x2 by 2. H2 is x1 plus x2 plus x3 by 3, and so on. And so on. Right? So if you want to just figure out, go by one more step, even H3 will be 1 into x4. You see, G3, G2 A4 is divided in the ratio 1:3 at G3. So and so on. So for G3, H3 would be 1 into x4 plus 3 into this expression. x1 plus x2 plus x3 divided by 3, this whole thing upon 4. Once again 3 will get cancelled. You are left with x1 plus x2 plus x3 plus x4 the whole upon 4. Now I hope the pattern is very clear. x1 plus x2 by 2, x1 plus x2 plus x3 by 3, x1 plus x2 plus x3 plus x4 by 4, right? So you just keep adding your xi, you will just have to divide by I, whatever is the last number. So by generalization, Gn, the nth point, which is Hn comma Kn, would be where Hn would be what? x1 plus x2 plus x3 up to, add it up to xn divided by n, right? Now this can also be written as x1 plus x2 plus x3 up to xn. There is a shortcut notation for it. Some of you may have seen it, some of you may not have seen it. Even if you have not seen it, just understand the notation. This is basically a sum up to n terms. We will write it as summation xi, I goes from 1 to n. Summation xi, I goes from 1 to n, meaning when I is 1, x1, x2, x3, x4 up to xn, right? This whole thing divided by n. So similarly, Kn would be again summation yi, I goes from 1 to n divided by n. So summation xi, many times you know that 1 to n many times is not written because it is understood that if you have n terms here, it is going to be added from 1 to n. Okay? So for example, here it is not explicitly mentioned, but summation xi upon n and summation yi upon n. As soon as you see this notation, you should understand summation xi means x1 plus x2 plus x3 up to xn. Okay, follow that, you will get the answer. Got it? Once again, even though it looks like we have written a lot in the exam, once you have practiced it well, you write 2-3 steps, you will know what is happening. Directly you will be able to write the answer. Okay? Alright, let us proceed then. If A, B, C are collinear points, A is equal to 3, 4, B equal to 7, C 7, and AC equal to 10, then C is what? Alright. So it is given that A, B, C are collinear. A is 3, 4, B is 7, 7. C we don't know, so call C as H, K, and AC is equal to 10, right? One way, of course, is to figure out what is the length of AB. Because if I know length of AB, then I know C divides AB externally in some ratio. I can figure out, once I know the ratio, I can figure out H, K. So let us do that, right? So let C be H, K, right? Now, what is AB? What is length AB? Under root 3 minus 7 the whole square plus 4 minus 7 the whole square, right? So that is under root, this is minus 4 the whole square, which is 16, and minus 3 the whole square, which is 9. And we know Pythagorean triplets, 16 plus 9, 25, under root 25 is 5, right? Which means we have these points A, B and C such that AB is 5, AC is 10, which is what is happening? BC must be 5, right? AB is 5, AC is 10, which means BC is 5, which simply means B is the midpoint. Correct? B is the midpoint. So I suppose now you realize what we are going to do. We'll apply midpoint formula, right? Which means B coordinates are known, no? 7, 7 is basically apply midpoint formula 3 plus h by 2, 4 plus k by 2. 3 plus h by 2, 4 plus k by 2. Right? 2 equations, 2 unknowns. You can figure it out. Let us just do it mentally itself. Cross multiply 2. 14 equal to 3 plus h, which means 14 minus, okay, let us write it down. 14 equal to 3 plus h, and cross multiply that other two, So 14 equal to 4 plus k. 14 equal to 4 plus k, right? So bring the 3 here, h is 11, k is 10, and c, which was h comma k, c, which was h comma k, becomes 11 comma 10. Correct? Is it there? It is not there in the options. That doesn't mean the answer is wrong. It just means this is not the answer they are looking for. Okay, so how do I figure out where did we go wrong? We didn't go wrong anywhere. Just keep in mind that we made an assumption which is not necessarily true. Okay, A was given, B was given. Who says that C is on the right side of B? We only know that AC is equal to 10. Right? Which means there is another possibility which is that C was on the left side of A. This is always possible. No one said that C is on the right side of B. But we know some other very important things. We know that AB is 5 and AC is 10. Right? This is also possible. Which means A divides CB in 2:1. Right? Which means once again we can apply section formula, or we will just use external division. We will say C divides AB externally in the ratio how much? 10:15, which is 2:3, right? 10:15, so 2:3, right? So now let us apply section formula once again for external division. Like I said, in section formula it is generally very useful to put all the information in the diagram itself. It is very helpful while writing the equations. So C is h comma k, A is 3 comma 4, B is 7 comma 7, and this is 2, this is 3. Alright, so which means h would be equal to, let us call this as x1 y1 and x2 y2, right? So h would be 2 into the other vertex, so 2x2 minus 3x1 upon 2 minus 3, right? So 2 into x2 is 7 minus 3 into x1 is 3 divided by 2 minus 3, which is how much? 14 minus 9. 14 minus 9 is 5. 5 upon minus 1. It is minus 5, right? And k is 2 into this coordinate, 2y2 minus 3y1 upon 2 minus 3, which is 2y2. So 2 into 7 minus 3 into y1, which is 4 upon minus 1. So 14 minus 12 plus 2 upon minus 1 is minus 2. Right? So minus 5 comma minus 2. C with C h comma k is minus 5 comma minus 2. Okay? Very interesting question. Why? Because you are likely to make a very common mistake here, and you will, if you look at the options, you will get confused. My answer is not there, must be wrong. Okay, so put a star mark and think about what happened in this question. The original assumption that we made, why that assumption is not always correct. Sometimes it will be correct, sometimes it won't be correct. So again, JE will always like to trick you in a way that you will always go for the common assumption, which means the answer will lie somewhere else. Okay, so practice this. Alright, let us proceed. The coordinates of the point which divides the line segment joining a plus b comma a minus b and a minus b comma a plus b in the ratio a is to b externally is what? Okay. So very straightforward, they're just asking us to apply section formula. If you take A, B, some point P, right? P divides in the ratio, AB in the ratio, A is to B, right? And externally, mind you, externally, so be careful. Let us take this point as B and this as P, right? So P divides this in the external in the ratio, A is to B. So this would be A and this would be B. Alright? Okay, so what are the coordinates of A? A plus B, comma, A minus B. What are the coordinates of B? A minus B, comma, A plus B. Very straightforward, P divides external division, so P divides, call P as H, comma, K. So, P, H, comma, K divides AB externally in A is to B, right? Which means directly we can say that H is equal to, if you want, once again for your convenience, mx2 minus nx1 upon m minus n, right? In this case, mx1 will be A is to B. So A into x2, if this is A, then this will be x2, right? So A into A minus B minus B into, by now I hope you understand what is M. This is M, this is N, this is x2 comma y2, so obviously this is x1 comma y1, that much you will understand. So M x2 minus N x1, so B into x1, which is A plus B, upon A minus B. A square minus AB minus AB minus B square. So A square minus 2AB minus B square upon A minus B. How many such options are there? A square minus 2AB minus B square is here and here, not here, not here. And between these two, A minus B is only here, which means one must be correct. One must be correct. Let us also verify. Right? We'll verify by finding out the y coordinate. And K is equal to M y2 minus N y1 upon M minus N, which is M is A y2 A plus B minus N B y1 A minus B upon A minus B. A square plus AB minus AB plus B square. So AB will get cancelled. A square plus B square upon A minus B, which is also there in option 1, right? Which means option 1 is correct, right? Which means H comma K is A square minus 2AB minus B square upon A minus B, comma A square plus B square upon A minus B. Okay, now this will definitely get us the answer, but in the exam what are you going to do? In the exam this will take a lot of time. Now often if you stare at the options for a few seconds, you will realize some options can definitely not be the correct answer. For example, we know that point P is dividing this whatever line segment in the ratio A is to B externally. Now if ratio is A is to B externally, it means in the denominator we will strictly have A minus B. Now how many options have A minus B in the denominator for both the coordinates? Is it there A minus B? No. A minus B? No. A minus B? Again no. Only the first answer has A minus B in the denominator for both coordinates. It must be correct. Are you following this? So, but of course this depends on observing for the options for a couple of seconds, which again you have to practice, but that is another method that can be used to eliminate. 3 options are eliminated, therefore 4th option must be correct. Got it? Okay, then let us proceed. If A minus 2, 5, B 3, 1 and PQ are the points of trisection of AB, then midpoint of PQ is what? Okay, very interesting question. A and B are given, minus 2 comma 5, 3 comma 1. P and Q are points of trisection of A and B. So P and Q are basically equally dividing AB into 3 parts, right? Midpoint of PQ, let us call midpoint of PQ some point M. Now one thing that we can do is, obviously, because this is trisection, using section formula you can find the coordinates of P, find the coordinates of Q, and then midpoint of PQ we can figure out. Or if you just stare at the diagram for a couple of seconds, we know by symmetry these 3 parts are equal, which means midpoint of M will also be midpoint of AB. Isn't it straightforward? As simple as that. PQ, they are dividing AB in 3 equal parts, so these 3 parts are equal, and then M is midpoint of PQ, which means automatically by default M also becomes midpoint of AB, right? If you are not clear, just observe. P and Q are points of trisection of AB, which means by default AP is equal to PQ is equal to BQ, and M is midpoint of PQ, which means PM equal to QM, right? So if PM equal to QM and these are also equal, I will just add AP here and BQ here. AP plus PM is equal to BQ plus QM, right? Because AP equal to BQ. And AP plus PM is what? AM. BQ plus QM is BM. AM equal to PM, therefore M is the midpoint of AB. Right? Actually, right now I am writing all this just in case you have not understood, but in the exam you don't have to write all this. You look at the diagram carefully, you will know that M is the midpoint of AB. And just apply midpoint formula. Which means M is minus 2 plus 3 by 2 comma 5 plus 1 by 2. 3 minus 2 is 1, 1 by 2 comma 6 by 2 is 3. 1 by 2 comma 3. Okay, this is actually a one line answer based on observation. Okay, that is, move on to the next question. The point whose coordinates are x equal to x1 plus t into x2 minus x1, y equal to y1 plus t into y2 minus y1 divides the join of x1 y1 x2 y2 in the ratio. So it is already mentioned that A is x1 y1 x2 y2, t the coordinates are given, right? Given p x1 plus t into x2 minus x1 comma y1 plus t into y2 minus y1, right? Let us call p h comma k. We need to figure out the ratio, correct? Now obviously we can write m by n or lambda upon 1 and then simplify it and then find out h comma k in terms of lambda is to 1 and then equate and then figure out. Or you can do something else. You can rearrange these terms to make it look like section formula. I can do that, no? So here h is x1 plus t into x2 minus x1. I want to rearrange this in the form of what? mx2 plus nx1 upon m plus n. So, which means first I need to separate x2 and x1. So separate that. I will write this as tx2 plus x1 and here also x1. So 1 minus t x1. Correct? Now it looks like mx2 plus nx1. For your understanding, let me write this in brackets. This is similar to mx2 plus nx1. But that upon m plus n is missing. It's not actually missing because this, what if I add m and n, t and 1 minus t? You get 1, right? So this is actually tx2 plus 1 minus t into x1 upon t plus 1 minus t. Beautiful, done. Because this is mx2 plus nx1 upon m plus n. Which means just by observation itself, this is section formula where m is t, n is 1 minus t, right? So, H is tx2 plus 1 minus t x1 upon t plus 1 minus t, which is similar to, let us use a slightly different symbol, which is similar to mx2 plus nx1 upon m plus n, right? So by comparing, no, not even by comparing, by matching we can see that m is to n. Don't write m equal to n equal to, but the ratio will be equal. M is to n is t is to 1 minus t. Okay, t upon 1 minus t. Got it? And then you can also verify by taking y, but you see this and this are following the exact pattern, which means automatically you get t upon 1 minus t. Alright. Now I want you to observe. So the answer is done. Consider this as a note. You see these forms, no? x1 plus t into x2 minus x1, y1 plus t into y2 minus y1. This is a very useful form when you want to write a general point between 2 points. Okay, a general point lying on the line joining 2 points, line segment joining 2 points. Okay, so x comma y equal to x1 plus t into x2 minus x1 comma y1 plus t into y2 minus y1 represents a general point on line segment joining 2 given points. Okay, so now question is, if it gives me points between 2 given points, then can it also give the end points? And yes, you will realize that if I put t equal to 0, you will just get x1 and y1, correct? And if I put t equal to 1, put t equal to 1, x1 plus x2 minus x1, x1 will get cancelled, you will get x2. So if I put t equal to 1, you will get y2. So putting t equal to 0 gives one endpoint, putting t equal to 1 gives the other endpoint, correct? Which is why this is a very useful form. Alright? Okay. Shall we proceed then? Let's do that. ABC is a triangle in which A 0, 2, B 4, 0. If 4, 4 is the midpoint of BC, then midpoint of AC is what? Alright. Since all the coordinates are given, let us just try and draw this. A is 0, 2. Okay. So A 0, 2. A would be on y-axis because x coordinate is 0. Similarly, B 4, 0. Y coordinate is 0. Therefore, B 4, 0. And 4, 4 is the midpoint of BC. So call this M 4, 4. This is the midpoint. So can you figure out what will be the other endpoint? You know, purely by symmetry, if I just extend this 4, 0, 4, 4, therefore this point C automatically must be, you see, if the midpoint is here, I want just this up. So this is 4 units, this should also be 4 units, 4, 8. Can you see that? I mean, of course you can use midpoint formula, you can use section formula, but what I'm trying to say is, this is 4, 0, This distance is 4 units. This is the midpoint. So this is also 4 units. So this should be 4,8. Right? Then they're asking about midpoint of AC. So just join A and C. Call this point N. Alright? So what will be coordinates of N? 0 plus 4 upon 2, 0 plus 4, 4 upon 2, 2, comma, 2 plus 8 upon 2, 10 by 2, 5. Done. Just asking for midpoint of AC, 2,5. Don't have to write anything. Purely by diagram you can get it, okay? But I will write down how we solved it so that you will understand it later when you read it. Okay, so M is, M M4, 4 is midpoint of BC where D is 4, 0, which means C is 4, 8, right? Which means N midpoint of AC is, now coordinates of A and C are known, so 0 plus 4 by 2, 2 plus 8 by 2, which of course comes out to 2, 5. Got it? 2, 5. Alright? Okay. Let us proceed. Alright, so looks like we have reached the end of the session. Thank you.